we bring to your attention a report on the topic: Building Cybersecurity Systems in Hybrid Cloud Ecosystems Based on Discrete Event Simulation. The nature of threats and vulnerabilities of information complex systems and hybrid cloud ecosystems in cyberspace is complex, heterogeneous, multifactorial, flexible, and rapidly changing. Traditional approaches to building security systems do not take into account many threats that are not obvious from the user's point of view. Ensuring security in cloud environments remains a pressing issue against the backdrop of the growing dependence of supporting the vital processes of the information society on cloud platforms and services based on cloud environments. Modern software, most applications are not developed from scratch. Some of the necessary functions are used from the ready-made functionality of other services, often cloud-based. At the same time, access to services is protected by various types of credentials, passwords, tokens, usernames, certificates, API keys, etc. In turn, such confidential credentials may not be reliably protected at the software development stage. As a result, the likelihood of misuse of resources and unauthorized access to information increases significantly and can lead to critical consequences. Examples are known. Many researchers confirm frequent leaks of confidential data through various channels: modern version control platforms, virtual server images, incorrectly configured cloud storage, large language models based on code-sharing platforms, mobile applications, mini applications, microservices, Docker containers, etc. The transition to new software architectures is leading to an increase in the problem of confidential data leakage and end-user losses. It is interesting to investigate the effectiveness of security processes and applications and platforms based on microservice architecture. Such hybrid ecosystems consist of many elements: the parent application server, the developer server, the hosting service, the services used by the developers, the client application, etc. A mandatory component of the joint efficient operation of all these elements is their constant joint authentication, which differs from user authentication on the platform or in applications. This is a type of technical authentication that allows an attacker to access various services on behalf of developers, which can be a significant vulnerability in the context of currently used insecure software development practices. Thus, the analysis shows that the nature of threats in cyberspace is heterogeneous, multifactorial, flexible, and rapidly changing. Traditional algorithms for detecting all threats at each access point and in each user application, including in the cloud environment, and neutralizing them are not effective. To research and develop new approaches to building data protection systems and analyze their effectiveness, there is a need to develop new approaches to modeling such systems, taking into account the features of integrated cloud environments. Usually, when modeling protection systems, it is proposed to use continuous modeling methods, the main features of which are as follows. The system is considered to be constantly changing in time. Time is the main parameter and often the criterion. Models continuously track the state of the system in the time dimension. It is suggested to change the viewing angle. Continuous monitoring or modeling of a complex hybrid ecosystem is a complex and resource-intensive task. It is proposed to investigate the possibility of applying a discrete approach to modeling systems with continuous information processes, in particular, to consider the principles of DES modeling. Unlike continuous modeling, the main features of DES are as follows. No changes between events. The main parameter is not time, but an event. The state of the system between moments of time does not matter. When modeling data protection in complex heterogeneous systems, including hybrid cloud ecosystems, we assume that, from the point of view of functional suitability, the state of protection systems is significant at the time of a cyber incident, attack, unauthorized access attempt, etc. Outside of the moments of attack and intrusion attempts, the state of the protected system is unimportant. At the same time, such a system can be considered as discrete, and the event that will affect the change in the system state is the moment of attack, and there is a finite set of such moments. Figure 1 shows the DES process of a data protection system in hybrid cloud ecosystems as a discrete event system. The properties of data protection systems in hybrid cloud ecosystems identified by the authors allow us to attribute them to discrete event systems, which are most widely used in the theory of automata with their variants, such as various graphs and the mathematical apparatus of Petri nets. To solve the problem of modeling protection systems, it is necessary that such a functional module can be located separately from the basic system. We will impose certain restrictions. We will assume that external influences from the environment are directed exclusively to the set of inputs, and the result can be considered exclusively in the set of outputs. This approach is inherent in functional networks, which have a more regular structure in the presence of these restrictions. Given that the defense systems under consideration will receive heterogeneous threats at the input positions and will require different times for the defense system to react, our model needs to include time delays for threat processing and determine the moment when the DES process is initiated. Let's get the model. It is also possible to increase the efficiency and accuracy of the analysis and the corresponding model built on the basis of hierarchical Petri nets. In this case, the same Petri nets can act as constituent elements. In the task of ensuring data protection in hybrid cloud environments, each nested element can identify different types of threats and/or perform direct protection actions. The mathematical model in this case will be as follows. The article reveals the complex and multifactorial nature of threats and vulnerabilities of information large systems and hybrid cloud ecosystems in cyberspace. The following properties of such systems are important to take into account: heterogeneity, hierarchy, multifactoriality, flexibility, and high speed of complex changes. Traditional approaches to building defense systems and corresponding algorithms are not effective enough and usually do not take into account a whole group of threats associated with the architectures of the developed defense systems. To research and develop new approaches to building data protection systems in hybrid cloud ecosystems and analyze their effectiveness, it is proposed to use DES technologies to model protection systems, taking into account the characteristics of hybrid complex systems. Is it enough to focus on the approaches proposed in this article for the problem under consideration? Certainly not. The research will continue. It would be advisable to consider other approaches for modeling complex security systems in cloud heterogeneous ecosystems that will allow first to effectively model and then find a platform for building such systems, taking into account the rapid changes in IT technologies, the growth of processed data, the development of quantum technologies, etc. Thank you for your attention.